The amount of sunlight that reaches the surface of the Earth in an hour and a half is sufficient to meet all of the world's energy needs for a complete year. Solar energy systems either use photovoltaic (PV) panels or mirrors to focus solar radiation to convert sunlight into electrical energy. This power can be converted into electricity, or it can be stored thermally or in batteries. Although photovoltaics (PV), which made the idea of solar energy a reality, has a long history, solar energy has only recently found a dynamic and established role in today's clean energy economy. What is a solar cell? A solar cell, also known as a photovoltaic cell or PV cell, is defined as an electrical device that converts light energy into electrical energy through the photovoltaic effect. A solar cell is basically a p-n junction diode. Solar cells are a form of photoelectric cell, defined as a device whose electrical characteristics, such as current, voltage, or resistance, vary when exposed to light. Solar panels, also known as modules or solar cells, are made up of individual solar cells. The maximum open circuit voltage that a typical silicon single-junction solar cell can generate is between 0.5 and 0.6 volts. This isn't much on its own, but keep in mind that these solar cells are tiny. Significant amounts of renewable energy can be produced when solar cells are joined to form a huge solar panel. What is the photovoltaic effect? The creation of voltage and electric current in a substance as a result of exposure to light is known as the photovoltaic effect. It is a natural chemical and physical occurrence. The construction of solar cell. The basic structure of a solar cell is similar to that of a p-n junction diode, despite some minor differences in manufacture. A p-type semiconductor is formed on top of an n-type semiconductor, which is comparatively thicker. On top of the p-type semiconductor layer, a few finer electrodes are subsequently applied. Solar photovoltaic systems. Solar cells produce direct current (DC), therefore they are only used for DC equipment. If an alternating current AC is needed for AC equipment or backup energy is needed, solar photovoltaic systems require other components in addition to solar modules. These components are specially designed to integrate into solar PV systems, that is to say, they are renewable energy products or energy conservation products, and one or more of the components may be included depending on the type of application. The components of the solar photovoltaic system are the solar module, which transforms sunlight directly into DC electricity, is a crucial part of any solar PV system. Solar charge controller regulates voltage and current from solar arrays, charges the battery, prevents the battery from overcharging, and also performs control over discharges. Battery stores current electricity that produces from solar arrays for use when sunlight is not visible, at nighttime, or for other purposes. Inverter is a critical component of any solar PV system that converts the DC power output of solar arrays into AC for AC appliances. Protecting electrical equipment from lightning damage and high voltage surges is known as lightning protection. For large-scale, crucial solar PV systems that incorporate effective grounding, it is necessary. Solar cell applications. Electrical devices, electric gate openers, security systems, ventilators, water pumps, water filters, and emergency lights are just a few examples. Lights for bus stops, phone booths, billboards, parking lots, indoor and outdoor areas, street lights, etc. Consumption, public services, irrigating mines, farming, and watering cattle, among other things. Emergency power system, battery charging center for rural village and power supply for household use and lighting in remote areas, etc. Water pumps, fumigators for agricultural products, thrashing equipment, water sprayers, etc. Pumping of water, fish farming oxygen system, insect trap illumination, etc. A refrigerator and a cold box for storing drugs, vaccinations, and other medical supplies. Navigational aids for the air, such as air warning lights, lighthouses, beacons, illuminated road signs, railroad crossing signs, street lighting, and emergency telephones. Microwave repeater station, telecommunication equipment, portable communication equipment, communication radio for service and military exercise and weather monitoring station, etc. Hill, islands, forests, and other distant regions without electrical systems, as well as the International Space Station and other spacecraft.